Okay, here we are. Today's video is gonna be called Honda Electronic Cruise Control. And I want you to take a schematic, take a snapshot of this and use it for the duration of this video. It will help you. I will go around and explain each component and how we're gonna be hooked in. Right now we're hooked in on 8 channels, and I will explain each one. And I will also take some scope captures with a 4-channel scope, and I will tell you when I'm there, and I'll tell you what channel is hooked to each to its specific component. But basically, this is the Honda Electronic Cruise Control. This car does not have drive-by-wire, but I guess I would call it almost a prerequisite to drive-by-wire, the way this system is set up. It is a very intelligent system. It uses a motor, a bipolar motor that is kind of similar to a drive-by-wire motor. It is duty cycled. Current can flow in either direction to make the motor put the throttle where it deems necessary. I'll start out by talking about this is the cruise control combo switch. This is on the steering wheel. It goes through the clock spring. I try to simplify the schematic for the sake of clarity to make everything pretty easy to understand. There is the set switch, there is the cancel switch, and there is the resume switch. The set switch also we're going to see is, we can also call that the set decel switch, and the resume switch we can also call that the resume accel switch. That will make more sense as we start to look at scope captures. In the middle is the cancel switch. As you can see, the way those diodes are, those blocking diodes, that if the cancel switch is selected, that the cruise control unit will see high voltage on the set terminal and the resume terminal at the same time, and infer that that is a cancel request from the driver to cancel cruise control. Anyway, to the left is the brake switch. That is a multi-pole switch. One pole works opposite the other, but they work. They both move in unison. They latch together. The one right here is the brake switch input to the cruise control unit. That's when the brake pedal is pushed down. That puts high voltage at the brake switch input. The other one will release what Honda refers to as the actuator clutch. As you can see, at that terminal of the cruise control unit, there's a lead coming out that goes through the brake switch down all the way over to the cruise control actuator, and there is the clutch. It kind of looks like an AC clutch. It's a solenoid with a spike suppression diode that will engage or disengage the cruise control motor to have control or not control of the throttle cable. I spelled cable wrong there. That was my bad. It was an oversight on me. Nonetheless, that is the throttle cable going over to the throttle body. There's the throttle position sensor at the throttle body. So nonetheless, that's kind of a safety feature that when cruise control is requested, that circuit is complete and the solenoid will engage the motor. When cruise control is desired to be canceled, that circuit, the brake switch, will open and current will no longer flow through that solenoid. It will disengage the motor from the throttle cable. Also down here between the cruise control unit and the PCM are two very important leads I want to talk about. One is called AT-COM or AT communication. Now, this is a smart system, and it goes into cruise control any speed above 25 miles per hour, so you may not be in high gear. So the PCM, which has pretty much control over the tranny, is going to have some duty cycle communication with the cruise control unit. You'll see in the scope captures that'll make more sense. It is basically a duty cycled piece of information, so the cruise control unit knows how to adapt for transmission shift changes. The other one is vehicle speed. That's super important. That is the speed. It's a frequency between the PCM and the cruise control unit. And in some of the scope captures, I will switch the leads. I will tell you when I'm on those particular channels. You'll probably see those on a 4-channel capture, but nonetheless, I'll make it readily clear that when we're scoping those two leads. So just bear that in mind. Other things, there's our scope. It's an 8-channel scope, initial hookup. Channel A and B is going to be at the cruise control unit. Those are our motor terminals. This is a bipolar motor that can go both ways. One terminal can be either high voltage or low voltage and vice versa. It duty cycles its command to that motor to kind of tailor it in the spot it wants to throttle. And channel A and B are going to be on each terminal of that motor. So you'll see that duty cycle. It'll either be high on blue and low on red, or low on blue and high on red. Channel C, green, we're going to current ramp this motor, and you'll see the current going either north or going south, depending on where the cruise control unit wants the throttle. Channel D, black, is a current ramp on the actuator clutch. I decided to use a current ramp instead of voltage. I think it has more value. We're going to current ramp when there's current flowing through that cruise control actuator clutch to disengage or engage the cruise control motor with the throttle cable. Channel E is going to be at the set input at the cruise control unit. That's when the driver requests cruise control. They hit the set switch, and that voltage goes high there. That is also a decel switch. So if you're cruising it, if you set the cruise at 55, and each time you tap set, it decreases the speed by 1 mile per hour, and the cruise control unit will sort of slowly change the angle of the throttle by accepting that request. And you'll see that on the scope. I have a few captures doing that. Cancel switches in the middle. That will feed both the set terminal and the resume terminal at the cruise control unit. The resume Excel terminal is another terminal that we're going to be scoping on channel F, the gray channel. And when we hit resume, that will feed 12 volts or full voltage to the resume terminal. And if we tap that, each time we tap that, it will increase the speed 1 mile per hour per tap as we tap on the resume switch to get the car back to its original speed. If you had to slow down for a policeman or somebody in front of you or an emergency, some situation when you're using cruise control and you want to get back to your original set speed. Channel G is the brake switch input at the cruise control unit. That's super important. We'll see that on the scope. That will cancel cruise control immediately as a safety feature, and all cruise control units have had some form of that. Channel H is the TPS. That's at the PCM. That's basically like we're sweep checking a TPS. It's a 0 to 5 volt range sensor, and that will change. You'll see that change in as we go through different cruise control situations, as we cancel the cruise control, as we engage the cruise control, we will see the TPS. And so anyway, we're going to go to the scope, and the first few captures are with 8 channels. We'll kind of take one channel at a time, so it doesn't look so clustered and intimidating. And some later captures I have with a 4-channel scope, which is obviously going to be a little easier to understand. But nonetheless, here we go. We're going over to the scope, and I'll start looking at captures. This has been done. The road testing has been completed. These are recorded captures, and we just lost our computer screen. Ain't that great? Okay, alrighty. Okay, and come on. Okay, let's see if it wants to cooperate. Okay, looks like we have a screen. Is it cocked? Is it cocked? Okay, we have a screen. Okay, that's just a frozen capture. I'm going to start and go through each of the situations. I'm going to go to the file, and we'll start to talk about each channel as I go through them. Here we go at 3:12. This was done at 3:12 in the afternoon on 4:15, and here we go. And we'll pull it up and talk about each. Take a look at your schematic. Real important that you print out your schematic and you follow it as you follow the video. It will make life a lot easier. Okay, here is basically before the cruise is engaged. The burgundy, as you can see, is the throttle. I can see I'm on the throttle a little bit, starting to ascend a little bit. And let's go to the next capture. Right now, we can see, take a look at your schematic and look where the set switch is. That's the purple channel. I hit set right there. That is a request for cruise control. So right there we have action. Now we start to see some things happen. We'll take one at a time. I know it's busy. Okay. First of all, let's take A and B first. Those are checking the voltage on each side of that motor. And as we look at that, it's duty cycled one way or another. And hence the current will be flowing one way or another. You'll see that throughout this video. talk about it more than just once, so I don't become redundant. But you can see the duty cycle going this way, okay, for a little while, and then it goes, the red becomes the positive side. So each motor is bipolar, it can go both ways. When the red is high, that's the voltage drop on the ground side, and vice versa for the blue. That's a little bit of voltage drop on the red side. Anyway, let's see. So we have red and blue are the commands to the motor. It's going to be either going one way or another to open or close the throttle. Purple right here is our set switch. That's when I hit set. The black channel is the current. That's the current flowing through that clutch at the cruise control actuator. He's even got a pintle hump. You know, there's our pintle hump. That means our solenoid actually physically moved and engaged the cruise control actuator motor with the throttle cable. So we can see that. Our gray channel is R. That is our resume accel, and there's no action happening there. That's staying low. Our throttle position sensor is right here. That's burgundy. I'm going to stretch that a little bit. Basically, that's our throttle right here. The cruise control engaged, and it kind of decided to put the throttle, took it down a little bit, but it's basically it's a controlled throttle because we can see duty cycle action here, and it has it probably about right there. The voltage right here, it's about 1.5 volts, and right down here, it's about a half a volt. So let's see what happens here. What did I do? Let's take a look at the brake pedal. Okay. The brake pedal was not touched. Something happened. We basically set the cruise here. I set the cruise, and right here you can see the gray channel. See the gray guy right here? I hit the resume accel button, and I held it down. So that's why this is high. You can see the throttle going up. The vehicle's accelerating because I have my finger on that resume accel button on the cruise control switch on the steering wheel. So that's definitely a correlation there between the command to accel and the throttle moving up. And obviously our duty cycle is doing its thing. The blue is the high and the red is the low, and the current is going in a specific direction in that situation to move that throttle motor more open. Okay, we go to the next frame, and right here I let off the resume accel, and you can see our throttle go down. The throttle is descending. The throttle is going down. The motor has commanded it to go that opposite way. Our clutch is still engaged, so our cruise control is engaged. Our actuator is latched to our throttle cable. So let's go to the next capture to see if we can notice anything interesting. Right here we have an abrupt shutdown, okay? And with something happened here. We know it wasn't the brake switch because the brake switch is always low. That's our orange guy right here. I did not step on the brake switch. I did not hit any of the set or the resume switches. They're purple and gray right here. Basically what happens here, I most likely shut the main switch off, which you don't see in the schematic. It's on the schematic on the vehicle, but you don't see it on the illustration unless, so I just manually shut the cruise control off, which is an option, is another way to shut it off. Basically the light on the instrument cluster would go out that says cruise control. Then I took control of the throttle, and I started to move up here. You can see that. I've got the throttle, I'm going up here, then across, and I kind of plateau right here till the next capture. Also notice that when I shut the main switch off, our current stopped flowing in the actuator clutch. So it basically it opened up the clutch between the actuator motor and the throttle cable. So basically that's a safety feature. And then basically I'm cruising along here, just driving down the road, and we are not in cruise control. That's my foot on the throttle going up and down a little bit. Basically I step on the brake here, and basically the car is going to come to pretty much a halt because I'm probably pulling over, and that's the end of that first capture. I'll go to the second capture and we'll talk about it. That was at 3:19. Right here, and we'll get to that guy. How we shooting? Okay. Okay. All right, let's go back to the initial part of the capture. And here we go. Here's the throttle. Here's the TPS voltage slowly going up. I just got off the brake pedal. You can see this. I'm probably coming away from a stop sign. The brake pedal's high. I put my foot off the brake pedal. Brake pedal goes low. Okay, next frame. Basically, I'm tapping here. I'm just kind of testing the set switch and the resume switch. You see the purple guy? Go. I'm just hitting these switches, and that's a high voltage feed to the cruise control unit. The main switch is not on. That's why we don't engage. There's the resume accel switch there in gray. Look at your schematic, and I'm just tapping those switches. They're just spring-loaded switches. They don't stay engaged when you hit them. They just spring back and either request set the cruise control or cancel. When they're both together, if you'll see these guys, we will see it later together. That means cancel. So nonetheless, here we go. We're going down the road, and now we got action right here. I hit the set switch. You see purple went high. Look at your schematic. That is the set position, and we have some duty cycle engagement. Our clutch locked, our actuator clutch locked. Our throttle's right here, and the cruise control actuator is putting the throttle where it deems it be. And as far as the brake switch, I'm not on the brake switch. The gray switch is, nothing's happening there. So let's keep going. And right here we got a little bit of action happening. It looks like we're going probably on and off, or, well, no, we'll see. Our clutch is staying engaged because our current continuously flows through our clutch at the actuator. Most likely the duty cycle is on and off until I get to the next frame, and right here something happens. Okay, hang on. Okay. Okay, I hit set over here, and it locked. The clutch it got engaged, and there's our throttle going up, up, up. Here I did something. I might have messed with the main switch, but nonetheless, let's see. Okay, no, I'm sorry. All right, there I held the gray. I held the resume accel switch down. That's why that gray voltage is high. And as you can see, the throttle. I'll put it in front. Okay, the throttle is ascending slowly because I'm holding down the resume switch. And right here you can see I'm tapping the resume switch. For each tap you get a 1 mile an hour increase, and you can see on the TPS voltage that it starts to look like that. You see the little undulations up and down. That's the command to raise that the vehicle speed 1 mile an hour per tap. That's pretty interesting the way it kind of it corroborates with the tap up command. Okay, anyway, we'll go to the next capture. And something happened here. Right about here, I stepped on the brake switch. So when you step on the brake switch, that's almost like everything's got to shut down. You see the current stops along through our actuator. Our clutch actuator motor, it disengages from the throttle cable, and the TPS is very abrupt. The shutdown, as you can see, is quite abrupt right here, and we're going down to basically a safe natural idle right along here. Let's go back here to our next situation. So right here, I'm off the brake pedal, and we got some engagement again. Our clutch actuated. How's our purple and our what made it engage? That wasn't that guy. And was it gray something? Okay. Basically, I hit resume here. You see when I just tapped up resume, so the cruise control unit has a memory now. It remembered the last speed. So once you just tap resume, it kind of accelerated. It's finding its way to that last vehicle speed, which was over here. So the thing has a memory. It's kind of, like an elephant. It has a pretty good memory. And it found it remembers where it was, and it was able to do that because I hit resume there. So anyway, our clutch is engaged, and we're in the next capture. I hit the brake right here, and it obviously disengaged. We see our current go low, and our throttle go down to its idle position. I hit resume again. our throttle starts to go up again into that mile per hour that it remembered. We see our duty cycle action here. We're high on blue, low on red. Here we're high on red, low on blue, and our current is corroborating. That current is flowing up this way or down this way. So that's because, remember, that is a bipolar motor. It goes both ways. Okay, let's go to the next capture, and basically anything interesting here. What do we have here? We have, okay, I am hitting the set switch, and that is making the cruise pretty much come and go. What is happening here? Okay, this is something interesting I want to talk about. Or is it? Okay, right here. This is a cancel request, and I wanted to key in on this. Right here, you can see we're high on purple and high on gray at the same time. Okay, that is if you look at your schematic, you know that it feeds the cruise control unit at 2 pins, and it's got the diodes to help it out, so current goes where it's supposed to, so that when that cruise control actuator sees it on both those terminals, it deduces this as that is a cancel request. And hence, we asked for the cancel request. We got the cancel request because you see our current went down. We unlatched the cruise control actuator, and we are running in regular non-cruise control mode right there. So let's go to the next one, and something happened here. I hit set again. You can see purple go high. You can see the there's our brake switch. Brake switch is not applied, but we can just see the action. See the okay, that's set. We have current flowing. Our clutch is engaged. Our duty cycle action takes place. Our current, it starts to flow through our motor to put our throttle in a certain position, and we're cruising down. And right here, something happened. Was it that shut us off? And let's see if we can determine that. It was not the brake switch. It was that cancel switch again. Okay, you can see again, gray and purple at the same time. Cancel request. We got our cancel request, and we are in non-cruise control mode. Something happened here. You can see purple without the gray tells us that we are in set. I just hit set here, and we set the cruise control, and it engaged here, and our throttle is going up, and we can see that. And where is our gray guy? Okay, now let's put gray in the front. Remember that gray is resume acceleration. So right now, I have my hand on the resume and I'm holding it down. You see our gray is long. That's resume acceleration. So it's actually moving the throttle. It's kind of accelerating the throttle without me putting my right foot on the gas. It's doing it through the cruise control actuator, and you can see the throttle sort of, it is very, very linear. It's very in line with that. The throttle is going up as I hold my finger on the resume accel switch. You can see that. That's pretty clear right there. Our duty cycle is doing its thing, and the next course of events are I'm tapping on the resume accel, and remember we got the 1 mile an hour increase for each tap, and then we can slowly start to see a little bit of an ascend in the throttle position sensor, and then I stopped doing it about right here. You can see it went away. I hit set over here, and it re-engaged it, obviously. And you could see that. Actually, I'm sorry, I misspoke. I hit cancel here. You can see our gray and our purple both high at the same time. Throttle going down. The cruise actuator is doing this thing to get that throttle back, and then it disengages the clutch. It actually had to work to put the throttle back to idle. You can see that work there between the red and the current flowing and the ground on blue, that it said, okay, he doesn't want cruise control anymore, we'll get him back to idle. It disengaged it right here, so that's a pretty smart system. Okay, next is basically we're not engaged, and my foot is on the brake, and I'm coming to a halt. That's charging system voltage. You see a little dip there? Honda's got a smart charging system, so it kind of fine-tunes the charging to see where it wants it. Anyway, so that's the end of that capture. We'll go to the next capture, and I'll talk about that. That was at 3:22 on 4:15, and we'll talk about that and see if there's anything interesting in that. Okay, we're here, and we have we're starting out. Okay, um, we have basically coming off an idle. There's our TPS right here. I got my foot into it slightly here, and I guess I made a request. I made a request to set the cruise control. I hit the set button here, not the resume button, so that's low. And so we got some action here. I'll blow it up. We got our motor doing its thing.